Okay, here we have a series parallel circuit. Alright, here's the example. There's the series part. There's the two parallel branches. Now you may ask yourself, well, how is it that these two are working and this is not even lit? What do you think would happen if I took this series part out of here? Well, let's do that. Let's just take that out of there for a second. Now, you notice how they're a little brighter? Okay. I'm going to hook it back up again and show you that. They're actually a lot less bright, but how much is a lot less? Okay. Let's get our trusty meter out for a second. Now, I got my meter out. Okay, I don't know if you can see that or not. It says 12.04. I'm set up to measure the source voltage. I got one lead in ground, one lead up here in the source. Now, the way a series parallel is set up is the series part allows the voltage to go through. You get up to the load that's in series, right? I got 12 volts. Now look, on the opposite side of this load, it says 11.63. So it looks to me like about almost 4/10 of a volt. I'll switch those around to get the minus sign out of there if it bugs you. Almost 4/10 of a volt dropped across this bulb, okay, that's in series. Now that would mean that if I started with 12, okay, we'll go back to here. If I started with 12 and I drop 4/10 of a volt, that means about 11.6 should be left to these two. Let me see if that is 11.62 there, 11.62 there. You see, that's applied equally and used up across each branch. Okay, used up across each branch. Now, if this was a higher rated resistor, suppose that was a 100 ohm resistor. Let's check that out first. Now, I've substituted a 100 ohm resistor for that bulb. So we've gone from dropping 4/10 of a volt. Now that the two lamps aren't even lit, but I have it on, I'm going to see how much voltage is available, just like before. We got 12 volts available. 12 volts available right to the first series part of the resistor. Now look at the opposite side. It says 0.96. So if I start with 12 there and I got 0.96, we'll say a volt was left. So that means if a volt's left, how much do you think was dropped across it? If we started with 12 and there's a volt left, it should say, look, 11. 11 volts dropped here. So that means then when you get over to here, to the parallel part, you got barely a volt left for each branch. And these are 12 volt bulbs, so it shouldn't be any surprise that it's not enough to make them light. Okay? Whatever is in series, in a series parallel circuit, some voltage is going to drop there. Whatever's left is then applied equally to the two parallel portions, or the parallel branches. If you had 2, 3, 4, however many parallel branches you have, okay? That's what you got to keep in mind. So if that was a ugly resistance at a junction point somewhere, and this was a lamp you had to have light, or a fuel pump or anything else, some voltage would drop, and if it wasn't enough to make it operate, you'd have a faulty operating component. That's why it's important to most mechanics to understand how series parallel works, because most circuits are either series parallel, or become so through unwanted resistance somewhere in series with the circuit. It could be unwanted in either end or unwanted within the branches. Now, I just touched that and it's blazing hot, so I'm going to turn that back off. But at any rate, questions, feedback is welcome. Thank you.